Hello, everybody, and welcome to our webinar on material flow cost accounting and the impact of signifying balance within the ISO 14051 framework. Material flow cost accounting, MFCA, offers several benefits to the process industry: cost reduction, environmental sustainability, enhanced resource efficiency, improved profitability, and compliance with standards and regulations. In this webinar, we will cover an overview of material flow cost accounting and show how Signifying plays a significant role in supporting MFCA through accurate data collection, material balance calculations, loss monitoring and reporting, process optimization. The material will be presented by Marco Lantieri, PIMSOFT's Industry Principal for Refining and Chemicals, and Felicia Moody, PIMSOFT's Industry Principal for Metals and Mining, Fertilizers, and Power. Following the presentation, they will be available for a live Q&A, so if you have any questions that come up during the webinar, kindly ask using the chat feature on the right-hand side, and we will answer them at the end. We thank you for your attention, and now I'll turn it over to Marco.
The question that gave birth to the material flow cost accounting is the following. What can enterprises do to ensure that they are economically sustainable and at the same time environmentally responsible? Material flow cost accounting approach has been incorporated and standardized in the ISO 14051-2011. ISO 14051 belongs to the same family of the more famous ISO 14001. Whilst ISO 14001 provides the requirements for the setup of an environmental management system, ISO 14051 provides a framework to make an organization understanding the potential impact of the material and energy use in its operation and on the environment as well as on the financials. MFCA is a concept originated in Germany in the late 90s, in the manufacturing industry mainly. It has seen quite a large adoption in Japan in the early 2000s, to be furtherly standardized by ISO in 2011. Although, given the origin, it has seen an historical adoption mostly on discrete and solid material flows, its adoption is increasing in liquid flows industry as well. Main achievements are an improved waste recovery, reduction in waste and material consumption, minimization of inventories, etc. MFCA becomes even more powerful when it is used in industries which has the possibility to consume recycled materials as feedstock, as the associated value of recycled material is often significantly different from raw materials, as we will see in one of the use cases that will be presented later. But how does MFCA methodology differ from traditional accounting? Well, whilst traditional accounting captures financial transactions and monetary values, MFCA captures data related to the physical flows of materials, energy, and is extended to consider the value of associated losses or waste. These are the four principles of material flow cost accounting. First of all, the flow of all materials and the energy used for each quantity center, so the envelope considering the analysis, should be traced to understand how materials are used and transformed along the whole process. So this implies the development of an appropriate flow sheet. Through MFCA, the environmental related decision-making process can be linked to financial information via the material flow model, which provides a better understanding of the real costs of material and energy, both for production but also waste generation, and results in an improved decision-making process. MFCA requires that all data to be verified at all inputs and outputs to be identified and quantified. It is recommended that all data to be converted to a common unit of measure. Using accurate and complete data is critical to identify the cause and source of any gap between inputs and outputs. And finally, real costs should be assigned to all material losses and products. When exact information is not available, the cost allocation should be as accurate and practical as possible. In MFCA, the information on costs attributed to material losses represents one of the main incentives for process improvement. Let's see the fundamental elements of MFCA. The quantity center is typically one or multiple process units. The center can be either a physical or a logical entity at which the material balance will be calculated both in physical and monetary units. One quantity center can include either a single process or multiple processes, depending on the amount of the material losses identified at the unit of production. Examples of quantity centers include points where materials are stocked or transformed, such as storages, production units, waste management, shipping and receiving points. In MFCA, all materials that goes into and leaves the quantity center should be balanced. For each quantity center, the amounts of inputs and outputs should be quantified. A material balance requires that the total amount of outputs, so of the products and material losses, to be equal to the total amount of inputs, taking into account any inventory change within the quantity center. Through MFCA, the material balance of inputs and outputs is linked to monetary units by assigning or allocating costs to all products and material losses. MFCA considers 4 types of costs, all of which are allocated to both products and material losses. So material costs, energy costs, system costs, and waste management costs. The material flow model refers to a visual representation of a process that shows all the quantity centers in which the materials are transformed, stocked, or used, as well as the flow of these materials within the system boundary. So now let's look more in detail to the classic balance for MFCA. So if the material balance is looked more closely, the classic approach given by MFCA is quite straightforward. Around the boundary, that can be the full facility or a specific quantity center, you consider the raw materials in input, the generated products, and by difference, the corresponding loss or waste production. Unfortunately, there are some shortcomings with this approach. Indeed, the classic approach is not considering the uncertainties regarding the quantities both of the inputs as well as of the products. Moreover, the considered loss and waste can differ from the real accountable losses and can overestimate the unaccountable ones. As many of you probably know, these are exactly the kind of gaps that Sigma Fine is asked to close. By applying Sigma Fine balance, error is minimized and reconciled losses are optimal due to the reduction of data inaccuracy. By closing this gap, over-allocation of waste and losses is reduced, resulting in more reliable figures for MFCA analysis, supporting a continuous improvement path and cost reduction. In doing so, Sigma Fine shapes the data in the proper context to be easily aggregated with cost tables, and typically monthly aggregated and then posted to the ERP level. Now, let's introduce a couple of case studies. The first one regards a wastewater treatment of a petrochemical plant. This is a simplified flow sheet of the fence balance, and inside some quantity centers are defined. A center refers to any significant area of a process where product waste and costs are of interest. MFCA quantity centers tend to be high-level diagrams, which will not have granularity down to each tank, meter, or pump. Due to data inaccuracy, the material balance is typically not closed. Indeed, if we look at the balance around the full facility and looking at the raw data, we see that there is quite a bit of imbalance, as well as a high level of uncertainty around the data. Applying Sigma Fine balance is valuable not only to close the balance, but moreover to reduce the high uncertainty in the numbers. Here we are only showing the value in mass, but in the MFCA framework, also cash equivalents are reported. Once we apply the mass balance and the error is minimized, we can compare the reconciled figures respect to the raw data. So the imbalance has been eliminated, all the material flows have been reassessed, and as you notice, there is both a significant reduction in the uncertainties as well as in the declared waste. If we look more closely to the most relevant items regarding the waste, so the slop oil and the sludge, there has been a reduction from respectively 104 and 100 tons to 86 and 90 tons per month. And the related uncertainty has decreased from 26% to 16% or less. So before we have shown figures for the overall balance. Here instead we show the cost allocation by quantity center. As you see, the highest costs of the plant are related to the waste sludge treatment and the slop oil separation units. The significant impact of mass balance that we have seen in the previous slides have been translated in 1.8% reduction of total annual costs. Additionally, thanks to process optimization after analyzing MFCA results, further achievements were reached, including minimization of excess activated sludge through ozonization and decrease annual waste from 0.6% to 0.3%. I will leave to my colleague Felicia to carry on with the second use case.
Hello, I'm Felicia, and now I will be taking you through this use case, which is related to the recovery of rare earth metals. Here is the raw data regarding the boundaries of the plant. The flow model takes into consideration several quantity centers, which are not shown in this schema, targeting different process units. But pay attention to the overall uncertainty. It is 17% in the overall balance. Also, there are high uncertainties both on the raw materials as well as on the products and on the waste. This is really a typical situation in metals and mining. As we know, the nature of the operating environment, it's hard to have continuous and reliable data. Applying SigmaFine is valuable not only to close the balance, but moreover to improve the data quality and uncertainty associated with these numbers. Here, only the mass is shown. However, in the full implementation of MFCA, cash equivalents are typically reported. After reconciliation, not only is the imbalance eliminated, but the huge improvement in data accuracy has been achieved, thanks to the very high redundancy in the associated SigmaFine input. Let's take a look at what was achieved. Indeed, the overall uncertainty dropped from 17% to less than 1%. Waste declaration has been reduced by over 3.5%. And we have seen an allocation shift from inventory to products. Let's wrap up. From previous case, we have learned that MFCA requires mass and energy balances to manage material and energy flows within organizations, which is one of the key capabilities of SigmaFine. Moreover, as declarations are often subject to auditing and other internal or even third-party requirements, SigmaFine platform provides native auditability and data processing capabilities. Furthermore, since the need of a tight integration with other systems in the company, such as ERPs, material handling, etc., SigmaFine integration framework is ready to offer bi-directional receive and pushback balanced data. Recalling this slide, which Marco presented earlier, we have seen at the beginning of this presentation, SigmaFine can be used to perform mass and energy balance models. SigmaFine can also be used to integrate cost tables to cover raw material costs, product, waste, utilities, and even additional costs such as needed, which allows one to perform and prepare the data needed for MFCA practice. Let's look at how this data can benefit the organization. By analyzing the more accurate reconciled data, plant managers and operators can identify inefficiencies in material and energy use, both at an overall view and also at the quantity center level, leading to cost savings and environmental impact reductions. track performances over time, enabling a continuous improvement within the organization. Being web-based, SigmaFind enables easy data sharing, visualization across the company. This slide is really for our users. It's call to action. If you're already a SigmaFind user, you probably already have in place a balanced model. By improving an existing templates, you may use your current SigmaFind to cover this additional functionality of your business, which is the mass and energy flow balances as defined by MFCA. Quantity centers can be identified by assigning proper SigmaFind attributes to the assets belonging to each QC. Monetary values can either be directly associated in SigmaFind, or more often, integration between material energy cost flow is done at the ERP level through SigmaFind integration framework. SigmaFind data can be aggregated over a defined period needed to perform the MFCA, typically on a monthly basis. Data can be shared across via reports. By analyzing data over time and combining not only reconciled values, but also SigmaFind data quality indicators, users can identify opportunities of improvement in their process and monitor performances over time. This is Marco and Felicia, and we thank you for taking the time out to join us, and we are here to answer any question you would like to ask. Thank you.
Thank you.
And thank you, Marco and Felicia. Got a few questions for y'all. If anybody else has any other questions, please use the chat on the right-hand side to send them in. First one, how do you move from an existing SigmaFind model to an MFCA model?
Okay, nice one. Okay, so as we shared today, MFCA looks at mass flows and energy flows. So this is where we start with SigmaFind. If you have just the mass balance, we would for sure would need to look at the energy. And also, if you are just looking on your production side, we would also need to look, we need to expand to the utility side as well. Those are the two, let's say, expansion we would need to do. Energy balance on the production side as well as on the utilities. The next step would be basically on the reporting side and aggregation, which we would be using, would be developing reports. If you have the SigmaFind SQL access, we can develop the reports via this technology, Microsoft SQL Service Reporting. There's also always Excel that's available. There are PowerPoint. So one is the balance itself, the analysis. That's on the back end. And on the front end, or consuming the data, we need to think about the report level, as we are going to be moving from the context of daily cases to typically a monthly case for the MFCA reporting. Thank you.
Okay, got another one. I don't think it's going to let me post the whole question at once. So I might have to do. In my company, we have adopted some monitoring based on the data. It's not exactly MFCA, but somehow similar, as we group information by cost center in our ERP. We don't use SigmaFind yet. What would it mean to implement something like the cases you showed to put in place a SigmaFind balance?
Okay, yeah. Yeah, long question. So, well, in case you want to, let's say, adopt the ISO framework, let's say SigmaFind can be a part of it. Of course, there is not a one-to-one overlap. The ISO framework is wider. SigmaFind will target exactly the effect of creating one of the best possible balances in terms of mass or of energy, and to shape the data in order to sort of contextualize the data needed for the association, typically with the ERP systems, where probably you are storing the pricing, the costs,
so all the monetary values as well. So let's say the first step I would suggest, just to comply also with the MFCA approach, is to understand what is the level of details that you want to place according to the balance. So which are the quantity centers that you are targeting? As we said before in the presentation, quantity center can be either more related to a physical asset, so you really want to see the inputs and outputs and related costs of each operating unit that you have in your process. But it could even be more abstract concept. So maybe you are targeting an overall supply chain, and you just find some nodes in your supply chain where to run the analysis. So quantity centers will be mapped in Sigma-Find models as nodes in terms of model topology. And then at the level of the asset description Sigma-Find, you can customize the asset description by creating specific attributes to identify which are the streams associated to which quantity center. You may decide to show monetary values directly in Sigma-Find, or you may prefer to keep it separate in the ERP. So this depends then on the implementation. But I would say the first thing to do is really to have an overall picture of how you want to shape your information respect to the different quantity centers. Of course, we are available maybe later and at the references provided in the presentation, and you can reach out to us to define more the use case.
Okay. We have some other questions. Great stuff from the team. How does the system integrate with Pi event frames, and what resolution is possible with the mass balances? Can it be used for near real-time accounting?
Well, let's say I would distinguish here, okay, the specific question respect to the, let's say, MFCA approach. So MFCA approach targets a much longer time frame. So most typically you are looking at monthly data, and you track the progress maybe over the year. Instead, let's say if we look at Sigma-Find capabilities as a product, okay, on one side, it's possible to perform mass balances on a whatever time frame you need, provided that you have the data. So it's not many times it's not the product technology the limitation, but it's the availability of the data. So, for example, if you have if you have all your data available in a real-time historian, okay, we can read those data and execute the balances on the fly. So I would say even not every second, but let's say on minutes level basis.
Yes.
But in several occasions, you are missing some of the information if not everything is readily available in a kind of real-time historian. I'm thinking to material transactions, which are one of the inputs in many process industries. I think of refining, but I guess really also in mining, you have you have transactions from trucks or rail cars.
Yes, exactly. This is
which makes it impossible physically to have all the data together. Regarding event frames, yes, you can integrate with Pi event frames in the sense that we can publish Sigma-Find results, and I'm talking not only about reconciled information, but also the statistical tests that are done by Sigma-Find. So the KPIs that you can use to diagnose data quality issues. And based on that, you can associate the generation of event frames or notifications as I mean, the backend is still Pi asset framework, as you may know. And so you can leverage all the Pi system technology behind.
Okay. We've got another question. Do you have users who use Sigmafine MFCA to be ISO 14051 certified? If not, how can MFCA tool help in the certification input data?
Okay, just to be clear, so ISO 14051 is not a certification directive. That is it's the most famous 14001.
Yes.
That is a certification. 14,000, the target instead of 14,051 is to give a kind of an operational procedure to to put in place practices to improve, assess your operations and related costs, especially related, as we have seen, to waste and loss management, and so to improve over time how you allocate the losses.
Yes, it's true.
So it's just to be specific.
Okay. What are specific advantages brought by applying Sigmafine to MFCA?
I'll take that one. So, as we said before, that MFCA scope, okay, it's much broader than the capabilities of Sigmafine. But within the targets of implementing a good MFCA, it requires good data, traceable, auditable. And because we are a data reconciliation software, we are using a least square analysis. Our job is to minimize the errors in the process data. This provides a foundation, a good foundation to have good data quality when you're talking about your MFCA and you're considering cost associated to the waste production. Again, we're scalable. We have different analyses. We can do the balances on energy basis, on mass basis, on volume basis. And this is the cornerstone in terms of the data, okay, that is required for MFCA. But for sure, as we mentioned, the goal of MFCA is not just to have good data and reporting, it is to reduce your losses and waste. So it should be within a framework, a management framework, and an operations framework, that this data is used to identify, let's say, weaknesses in the organization. The organization takes response, things are put in place, okay? They can even decide to put, let's say, a better waste treatment facility, and then the model needs to be updated. So it is a circle, and we are a part of it. And our part of the MFCA circle is capturing the data, the process data, improving the data quality. When the operation has implemented, let's say, a physical asset or change in its operation, we have to update this. So it's integrated into the operations, but we are not the MFCA.
Okay. I think that's it for the questions as of now. Thank you, Marco. Thank you, Felicia.
Thank you.
Thanks to all the attendees.
Thank you for joining us.
And we will be making this available, both the presentation and a copy of the webinar or recording, to everybody that has registered. We should be sending that out here in the next day or two. Thank you for attending, and we hope to see you at the next one. Thanks. Bye.
Thank you. Bye.